Let's see. So they kind of gave you guidelines on what to do. But are you going to have those memorized? Maybe. So if you don't have those guidelines memorized, what else could you do there? That's about all you could do, isn't it? Maybe you could choose two different powers. You could rewrite tangent as tan cubed times tan squared. You could do that. What good does this one do you? I can rewrite tan to the fourth as tan squared squared. Believe me, you're hoping that you have that table supplied to you on the next exam. Yes and no. Portions of that table, of those tables at the back of the book, will be supplied on the next exam. Because I may give you a problem like this and say use the table in order to solve it. In which case you won't have to do any integral, you just have to be able to use that formula. Well, what good did this do?
Yes, use substitution.
Well, I could do a u substitution, but what good would it do me? Derivative of tangent is secant squared, so there's no substitution there that I see. But I also see that, well, tan squared could be rewritten as secant squared minus 1. Is that going to do me any good? How?
U equals tan? U equals tan,
Well, if I let u equal tan, what I would need to have is a secant squared x dx. I do not have that. That's what we're trying to get to. But see, what I don't want to do is just pick a problem and then just start doing it the right way. I mean, when I put a problem on the test and you look at it, you don't say to yourself, there's the right way to do it. What you ask yourself is, well, what can I do? What are my options here? That's why when I first looked at tan to the fifth, I said, well, what can I do to that? Well, I could split it up as two different powers of the tangent. Not that I know that that's going to work, but what else can I do? I had no other option. So having chosen that now and said I didn't know what else to do, well, then it sort of came to mind, I don't know what to do. I guess I'll just play around. I'll try to change tangents into secants. What good did that do? Well, again, I still don't see a substitution. I don't want to let u equal tangent because then I get secant squared x dx, but I don't have secant squared times dx. I got secant squared all locked up in there, which kind of tells me maybe I should unlock the secant squared from those parentheses. Maybe that would help. So let's see, that's why I had these two suggestions over here to expand. Not because you just knew that was the right thing to do, but what else can you do? What else is there? So I'm going to expand this out. I still don't know whether this is going to help or not, but maybe it will. So you get secant to the fourth minus 2 secant squared x plus 1 tan x dx. Let's see if that did any good. How am I going to tell?
Secant's going to be your u.
What's that?
You just distribute tangent.
So keep on expanding. So in other words, I've got secant to the fourth x tan x dx minus 2 integrals secant squared x tan x dx plus integral tan x dx. So I like this so far in that of those 3 integrals generated, I know absolutely how to do the last 2. I have a formula memorized for the last one. How do I deal with this one? U equal tangent, du is secant squared x dx. Well, what about this? I have the same thing going on here. I can now take this one and I rewrite it as secant squared x times secant squared x tan x dx minus 2 integrals tan x secant squared x dx plus integral tan x dx. See, this is good because I take one of these secant squareds and rewrite them as
10.
1 plus 10.
1 plus tan squared. So now I'm going to take this, I'm going to rewrite it as tan x times 1 plus tan squared x times secant squared x dx minus 2 integrals tan x secant squared x dx plus ln absolute value secant x. I guess I'm going to add an arbitrary constant on to the end of the last. Right, now both of these two integrals we've just generated will be solved by the same substitution, u equal tan x. Then what's du? Secant squared x dx. So now we've got integral u, 1 plus u squared. Secant squared x dx is du, minus 2 integrals u du plus ln absolute value secant x. Well, these are now easily done, and once you integrate them, you back substitute for u. So in the interest of saving time, I'm just going to put a dot, 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 and you cannot do that on the exam. Question. Is everybody cool with that? Everybody see how it's going to finish now? All right, you're going to multiply this out. You're going to integrate u cubed. You're going to integrate u to the 1. Here you're going to integrate u to the 1. At the very end, you'll replace all the occurrences of u with tan. Questions?